Okay, so in this video we'll add the columns and the pipes to the game. Okay, so to do this, first of all we need to go to the sprites folder and we have to locate the pipes. So just click on one pipe and drag it to the hierarchy. We'll call this pipe 1, for example, and now drag the other pipe, select the other pipe, the pipe that goes upside down, and we'll call it pipe 2. We will add some box colliders to the pipe, so select pipe 1, add a component, add the box collider, a box collider 2D, and we'll do the same thing for pipe 2, add a box collider 2D component. Alright, so now you can see that we cannot see them here in the game. That's because of the layer that the pipes have currently. So currently the pipes have the sorting layer set to default, so let's change that to maybe midground. Yeah, midground is a good one. And change the layer of the other pipe to midground too. Alright, so now we have our both pipes here in the scene and we can also see them in the game. Alright, so now we have to set a distance from each pipe. So what's gonna be the distance? So to do this, we're going to first of all make sure that both pipes are at position 0 along the x-axis. Okay, so now what we have to do is that for the first pipe, for pipe 1, we're going to set the position to -1.05. -1.05, and for the pipe 2 we're going to set the position to 1.05. okay, so this is gonna be the distance that they're gonna have from each other. Okay, so now that we have both pipes, we need another game object that is going to act as a container of the pipes, and we're going to call this game object column. So to create a column, go to make sure you're here in the hierarchy, right click, select create empty, and of course we need to reset the transform of the object, so reset the transform component. Now we're gonna call this object column, and this column is gonna be the container of both pipes. So now we're going to select both pipes, hitting control, so holding control, we're going to select both pipes and we're gonna drag them to the column like this. So by dragging them, we just made that the pipes become children of the column. So now if we move the column, we can see that the pipes also move. Okay, so now that we have our column here, we only need to make it move, okay, to the left. So we already have a script that has that behavior of moving to the left, and is the script that we attach to the ground. So we're gonna go to the assets, to the scripts, and we're gonna attach the move left script to the column. So you can just drag it to the column like this. And now if we select the column, we can see that it has the move left script and it has a speed. So let's set the speed to 0.5. Alright, so in theory, everything should work now, right? Because we have attached the same behavior. But there is one little problem. And the problem is that if we go to Visual Studio, we can see that in the move left script, we did this only for the ground. So in here, in the start method, we are accessing the box collider 2D. So, but we're accessing the box collider 2D of the ground. If we look here in the Unity editor, we can see that our column does not have a box collider. So at the start of the game, if we go ahead and play the game, it's gonna give us an error. The column is going to move to the left, but if we look here in the console, we can see our first error here. We can see that it says missing component exception. There is no collider 2D attached to the column game object. Okay, so what we want to do is that we want to use this script for both objects. We want to use this script for the ground, and we want to use this script for the column, but we want to modify this script depending on whether the game object is a column or a ground. So to do this, we can do this with the help of tags. So if we go here in the Unity editor, we can select our column, for example, and we can see that here in the inspector, below the name, there's a field called tag, and it says untagged, because right now, currently it doesn't have any tag. So we can just click here and select a tag, and we're gonna select two tags. We're gonna create a tag for the ground, so type in ground, click save, and now click the plus button again, and we're gonna type in column for the column and click save. Okay, so now we have two tags. So now we can modify the script, and according to those tags we can specify different behavior. Okay, so to do this, for example, inside the start method, we could say if game object. So when I say game object, I'm referring to the game object to the game object that this script is attached to. So if game object dot compare tag, so when I use the compare tag method, I'm comparing the tag of this game object to a string. So we're going to compare the tag to the ground. So we do it like this. If game object dot compare tag and ground, so if the tag of this game object is ground, then we want to do this. Then we want to actually access the box collider component. Else, we can say else if game object dot game dot compare tag, and here we can check if the game object has a tag of column, for example. So if the tag of the game object is column, then we want to do something else. So if we do this and we hit Ctrl S and we go back to the Unity editor and we press play, now we can see that we don't have that error anymore, which is great because we didn't want to have that error. We have avoided having this error. And in here, what we can do is that we can reset the position of the pipe. But before resetting the position of the pipe, let's do something else. Here in the Unity editor, you can see that we have one pipe, and the pipe goes and it disappears, and that's the end of the story. So how could we have more game objects? Okay, so one solution could be to create copies of the column, right? I could press Ctrl D, Ctrl D, Ctrl D, and duplicate the columns and create different columns like this, right? I could create different columns at different positions, then I could hit play, and then the columns will work like this. Okay, and now you can see that there's a little bit of a problem. The ground stops moving, and this is because our ground, we have defined the tags, but we haven't specified the tags for the game object. So if we select the ground here, you can see that the tag is untagged. So select ground. So for the grounds, make sure that they have the ground tag, and for the columns, make sure that they have the column tag. Okay. So right now we have these columns, but they don't work as we expected, right? Because if they go like this, I mean, then they finish, and then what happens? So what we do in this case is that we use a spawner. So we have to spawn the columns randomly. We're going to create a column spawner. So let's delete this columns and let's create a column spawner. But to create a column spawner, we need a reference to the column that we're gonna create. So we have to create copies of this column inside the code, and then we have to spawn them from the script. So to do this, we have to create what we call a prefab. So if you don't know what a prefab is basically an object that we created here in the hierarchy with a pipe and with, for example, this is an object that we created. It's called column and it has pipes. And what we need to do now is that we need to create a prefab from this. So we can use the prefab anytime we want. So to do this, we're going to go to assets and create a new folder. So let's create a new folder called prefabs. Okay, let's do everything one thing at a time. So let's open the prefabs folder, and then let's drag this column to the prefabs folder. And now we have created a prefab. Now you can drag the column as many times as you want. And you don't need to hit Ctrl D to copy. Now you can just create columns like this, which is perfect. And you can see that we can create many columns, and if we hit play, we can see that the columns work fine, but of course the space between the columns is not the right one. But you can see that we have created our columns. So what we are going to create now is a column spawner. So select these columns and delete them. And we can delete all the columns now because we have the prefab. And what we're going to do now is that we're going to create the column spawner. So to create the column spawner, in the hierarchy, right click and select create empty. We're going to call this game object column spawner. We're going to reset the transform position. Okay, and then we're going to drag the column spawner all the way to the right. But as you can see, this column spawner will not have a sprite or anything like it. So, and if we press somewhere else in the scene, we stop seeing the column spawner. So how can we see the column spawner? So select the column spawner and drag the game view all the way to the right like this. And here you will see there's like a tab called gizmos. So click on this tab, and here you can see that we can change the size of the 3D icons, right? So right now we're gonna leave the icon like this for now. And what we're going to do now is that we're gonna go here we're going to select the column spanner, and we're gonna go to where the name of the column spanner is in the inspector, and right next to it there's like a square with an arrow pointing down. So click this square, and now you can select an icon. So we're going to select this diamond, this red diamond over here. So select this red diamond, and now in the scene, if you can see that there's a red diamond here. So this red diamond indicates where the column spanner is. So we select the column spanner, you can see that in fact that it is the red diamond. Okay, so we'll set the column spanner over here, and now we need to create a new script for the column spanner. So let's go back to the assets and to our scripts, and inside here we're going to create a new C# script, and we're going to call it column spanner, like this. Okay, now we're going to open the column spanner, and inside here the first thing that we need to know is that we need to know a reference to the column. Okay, so let's create a reference. So to create a reference, we need to type in the data type of the column. So we could say column, right? We could say column. We could say column if we had a script called column, but we don't have a script called column. If we go here to our column spanner, we can see that it is a game object and it has no scripts whatsoever. And if we go to our prefab, to our column prefab, okay, we can see that it has a move left script. So we can actually go here and say move left like this, but we're not going to do this. We're going to say game object like this. Game object means that this is of type game object. So we're going to create a reference of type game object called column, and then we're going to just type in a semicolon. So this is the reference, and we want to make it public because we want to edit it from the inspector. So let's make this reference public. And what we're going to do is that we're going to create a new method called spawn column, and this method is going to spawn a column or instantiate a column every time that it is called. So here we can say void instantiate column. So every time we call this method, we're going to instantiate a column. And here what we're going to do is that first of all, we're going to create an object of type game object called new column. And this game object, this new column object is going to be a copy of the reference that we have of our column. So this is going to be equal to instantiate column. So we're going to instantiate our column object. And now what we're going to do is that we're going to set is transform.position equal to a new vector2. And the transform.position of this column is going to be the transform.position of the spawner, the transform.position.x of the spawner, and in the y component we're going to set a random value. So we're going to set a random y like this. So because we don't want the position along the y-axis to be the same, we want to have every time we spawn a new column, we want a different position. So here I said transform.position, but actually we have to say new column because we want to alter the transform.position of the new column. And here you can see that rand y gives us an error because we haven't specified the value for this. Okay, so what we have to do here is that we have to create two random numbers. What we have to create is a random value for the y-axis. So here at the top of the class, we're going to specify the max y. So we're going to specify the max value for the random y and the minimum value for the random y. So we're going to say public float max y. So this is going to be the maximum value for the random value, and the minimum value for the random value is going to be float min y. We're going to assign these values from the inspector. Okay, so we're going to set them in the inspector, and what we need here to do is we need here to create a float just called rand y like this. Okay, so now we don't have any errors here with our random position, but we need to actually every time we create a new instance a new column. Every time we create a new column, we need to set the value for the random value. So rand_y equals random dot range. This is how we create how we create random values in Unity. So we say random dot range, and inside the parentheses we specify the minimum value and the maximum value for the random number. So the minimum value is min y and the maximum value is max y. Okay, so now we have created a random value. We are creating the new column object that is a copy of the column reference that we have, and then we are assigning we're setting the transform.position of the new column equal to the transform.position.x of the column spawner and the random y position that we created here. Okay, so now we need to call the instantiate column. So first of all, let's call the instantiate column from the start method. So instantiate column like this, and see what happens. Okay, so now we're gonna hit Control S. Let's go back to the Unity editor. Do not forget to assign the column spawner script to the column spawner object, because if you don't assign it, it won't work. So here we're gonna add a component to the column spawner. So we're gonna add the column spawner game object. For the max y, we're going to set 0.6, and for the min y, we're going to set minus 0.2. Okay, and now we need a reference to our column. And as I said before, once we create a prefab, we can use this prefab to assign the reference, to make a reference to this prefab. So that's why we create a prefab. We create a prefab. A prefab, you can think of a prefab as a special game object that it is not initially in our scene or our game, but that we can make a reference to later on from other scripts. In this case, we're making a reference we're gonna make a reference to this column from the column spawner script. So just drag the column to where it says column here. So now we have a reference to this prefab, and we can create instances or copies from this prefab. Okay, so now if you hit Control S and you play the game, at the start of the game, you can see that we have spawned one column. Okay, but we want to create many different columns. Okay, so to create many columns, we have to call this method inside Visual Studio. We need to call this method, the instantiate column, inside the update method. But we want to call it every X amount of seconds. If we just call it like this, instantiate column, and we hit Control S and we go to the Unity editor and we play the game, it's going to instantiate 60 columns per second, which is a lot of columns. So to fix this problem, we need to create a maximum. We need to get a value called float max time. This value will indicate the maximum time between each spawn, and this time we're going to, so the max time we're going to edit it from the inspector, so public max time. And then we also need to create a variable that is gonna be called timer, so float timer. So what we're going to do here is that we're going to update the value of timer in each frame, and when timer is greater than 1, for example, so when timer is 1 second, when timer is greater than max time, and max time, for example, can be 1.5, for example, and if timer is greater than 1.5, then we want to instantiate a column. So here we want to, first of all, we want to okay, not in the start method, but in the update method, what we want to do is that in every frame we want to update the value of our timer. So in every frame we want to say timer plus equals time dot delta time. So here what we're saying is that we want our timer to update by time dot delta time in each frame. So this means that the timer will be like, for example, if timer is greater than 1, it means that one second has passed. So we're updating timer, and here we're going to check if timer is greater or equal to max time. So if timer is greater or equal to max time, then what we're going to do is that we're going to instantiate a column. And after we instantiate a column, we have to reset the timer. So timer equals 0. So every frame timer is gonna be increasing in every frame, and when timer is equal or greater than max time, we're going to extension that column, and then the timer is going to be equal to 0. All right, so save, go back to the Unity editor, and here you can see that now we have a new field. If you select the column spawner, you can see that we have to indicate the max time. So let's put in 1.5, for example. Let's hit Control S and let's play the game. And now every 1.5 seconds you can see that we have a new column spawned. Okay, so now the game looks pretty nice. It actually looks like a Flappy Bird. So we're doing well so far. But you can see that there is one problem. The problem is that if you zoom out a little bit and we play the game, you can see that every time we go through a pipe, the pipe goes off the screen. The pipe does not disappear. The pipe goes to the infinite, and this is gonna take memory away from our game. So to solve this problem, we need to actually destroy the pipe when it gets out of the screen. So we do that in the move left script in here. And how do we do this? Okay, so to do this, what we need to do first of all is that we need to, here when we're in the start method and we say game object, we know that we are making reference to a column. We want to get access to the pipe width, okay? Because with the column does not have a sprite, but the pipe has a box collider, okay? And the box collider gives us the size of the pipe. So to do this, we're going to create a new variable over here. So float, and we're gonna call this variable pipe width, like this. And here we're gonna set the pipe width. So we're gonna say pipe width equals to find to, okay, so to game object. So this is the class game object. So we're gonna say game object dot find game object with tag. So what this function does is that it lets us find a game object with a specific tag. So the game object we want to find is the game object with the tag pipe, like this. We haven't defined the tag pipe yet, but we're gonna do it right now. And it's gonna find the game object with the type pipe, and then we're gonna type in a dot, and we're going to say get component. So once we get the object, we're going to say get component, and once we get the component, we have to specify which component we want to get. So we want to get the box collider component, the box collider 2D component. So get component box collider 2D, like this. And once we get the box collider 2D, we want to get the size dot x. Okay, so we get I know it's a very long line of code, but basically what we're doing is that we're finding a game object with a tag pipe, then we're getting its component, its box collider 2D component, because the pipe has a box collider 2D, and then we know that the pipe has a box collider 2D, so we want to access the size and the x value. So we get the pipe width, and we're gonna use this pipe width right now, and we're gonna do it here in the update method. So in the update method, first of all, we're gonna check if the game object dot compare tag, and inside we're gonna see if it's the ground. So if it's the ground, we want to reset the position of the ground. So command X, command paste. So we want to do this. If it's the ground, we want to reset the transform position of the ground, and we're going to say else if game object dot compare tag. We're going to see if the tag is equal to column. So if it's a column that it's moving, we want to check if the transformed position of the column, so if the transformed position dot x of the column is less than the edge of the screen minus the pipe width. So how do we get the edge of the screen? So to get the edge of the screen, what we're going to do is that we're going to create a new C# script. Okay, we're going to go to the console, to the assets, and inside the scripts, we're going to create a new C# script. So create a C# script, and this C# script, we're going to call it game manager. We're actually going to create a new game manager object here in the hierarchy. So right click and create empty, and reset the transform position, and we call this game object game manager. Okay, so now we're gonna attach this. Looks like a gear, but it's a script, so don't worry about this. And drag the game manager to the game manager object. Okay, for some reason it doesn't let us manager. Okay, it says that there's an error here, and that's the reason why it cannot let us do the things. Okay, let me see. Okay, so if there's a compile error, it means it won't let us attach the script to the game object for some reason. Okay, so now the game manager has a game manager script. Let's open this game manager script, and inside here basically we're going to specify common data that is going to be very important for our game. Okay, and the game manager basically is that what handles our game, the game states, etc. So that's why we create a game manager. But it's like a normal class. It's just the same. It's like any other class. Okay, so inside here we're going to create a public static vector2, and we're gonna call this vector2 bottom left. All right, so what is a static variable? So a static variable means that what you should need to know for now is that a static variable means that we can call this variable by calling the class. So we can say game manager dot bottom left, and we can access this bottom left just by calling the name of the class. We don't have to create an instance like we always do. We don't have to create an object to access the variable if the variable is static. Okay. All right, so what we're going to do here is that we're going to do something in a method called the awake method. I know it's a lot of new information, but just bear with me for now. Okay, so the awake method, what you need to know about the awake method is that this method runs before the start method. So the start method runs before the update method, and the awake method runs before the start method. All right, so in the awake method, we're going to set the value of bottom left. So we're going to say that bottom left is equal to camera, so to the camera dot main dot screen to world to so screen to world point. We want to transform this. What this basically means is that we want to transform a screen point to a world point. So in the Unity editor, if you go back to the Unity editor and you zoom in here in the scene, you can, if you select the main camera, you can see the outline of the camera over here. It's this white outline over here. So bottom left, what I mean by bottom left, I mean this edge of the camera over here. You cannot see it very much because it's on top of everything, but if we move the camera a little bit to the left, now you can see the outline of the camera. So the bottom left is this edge over here. This is the position that I want to get, because remember that we want to get a reference to this edge of the screen. So that's what we want to do for now. Okay, so here in the game manager, what we're going to do is that we're going to say camera.main screen to world point, and in the parentheses we're going to transform the point that we want. So we want to transform, and we want to pass in the position. So new vector2. So new vector2, and inside the parentheses I'm gonna put in a 0, 0 like this. And what we're doing here is that we're transforming this position, the 0, 0 position of the camera, because remember that the 0, 0 position of Unity is this. This is the 0, 0 position of Unity, but the 0, 0 position of the camera is this one over here. All right, so now that we have the bottom left defined, I know this was a little bit weird, but now that we have the bottom left vector2 defined, now we can go back to the move left script, and here we can say that if the transform position.x of the column is less than bottom left. Also, okay, now we want to call the bottom left vector2. So we said that to call a static variable, first of all we need to call the class. So game manager dot bottom left, and then we have to say minus pipe width. Okay, so it was a little bit confusing. Sorry if it was confusing, but we're getting the game manager bottom left dot x minus width, because if you say game manager.bottom left, this is a vector too. So if you wanted this to be a float, it has to be .x, because the x component is a float. So if the transform position of the column is less than the game manager.bottom left.x minus the pipe width, then we want to destroy the game object. Okay, so this should work. Let's go back to Unity and select the game manager and make sure that it has the game manager script attached to it. Now let's hit play. And you can see that there's an error that says that the tag pipe is not defined. If you remember, if we go back to the move left, you can see that here, when we declare the pipe width, we're trying to find a game object with the tag pipe, but in the Unity editor we haven't defined the tag pipe. So to define it, go to the project view and then go to the prefabs, open the prefab. So double click on the prefab. This will open the prefab. So any changes you make to this prefab will apply to all the instances that you make from this prefab. So now that we have opened this prefab, you have to take a look at what this prefab has. Okay, so it has a column and it has two pipes. So we need to add the pipe tag to these pipes. So select the pipe, select the first pipe, and here in the tag, select add tag. And right now we have the ground tag and the column tag. Let's add in the pipe tag. So pipe, save. And now we can select our pipe and assign the pipe tag to it, and select our pipe 2 and assign our pipe tag to it. So now hit Ctrl S. You can go back if you want to go back to the previous window. Here in the hierarchy, just click this arrow and you'll go back to the scene, to the main scene. And now we can click play. And now you can see that we have no errors. And now you can see that, and you can see in the scene that every time the pipe gets off the screen, it destroys itself, which is great for our game performance. And our Flappy Bird is moving great. Okay, so this is going to be it for this video. It was a long video, but I hope you enjoyed it. And I'll see you in the next video.